So we'll continue from the last video or lecture. In the last lecture we have calculated AST requirement for positive and negative bending moment in the column strip. Now we'll start with the steel requirement calculation for middle strip. Okay, along shorter and longer span the steel requirement is same because our span or panel is a square panel. Okay, so AST for negative bending moment comes out to be around at 140 mm center to center, and for positive bending moment, that is at the central portion, the spacing comes out to be 180 mm center to center. Now we will start with the steel calculation for middle strip. Okay, so consider C step number C. Okay, that is for negative moment in middle strip. For negative moment in the middle strip, we have already calculated this bending moment was 65 kilonewton meter, and at the middle strip the depth, and at depth D is equal to 190 mm, whereas total depth capital D is 220 mm. Therefore we can calculate AST by using our AST formula, that is AST is equal to 0.5 FCK divided by Fy multiplied by 1 minus square root of 1 minus 4.6 mu upon FCK BD square multiplied by B into D. Just put the required values here. 0.5 FCK is 20, Fy is 415, 1 minus square root of 1 minus 4.6 into mu is given as 65, so 65 into 10 raised to power 6, converted it into Newton mm, divided by FCK is 20. B, the width of your middle strip was 3000 mm, and D is 190 square. So multiply this whole term with 3000, that is B, into D, that is 190. So AST comes out to be 983 mm square. So this is the AST requirement for negative bending moment in the middle strip. Okay, now we will calculate the percentage AST. This is our AST calculated. Therefore percentage AST, the formula for calculating percentage AST is AST divided by B into D multiplied by 100. So this is equal to, we have AST is equal to 983 divided by B is 3000 multiplied by D. Okay, sorry, this should be capital D. This should be capital D. So this is 220 multiplied by 100. So percentage comes out to be 0.15%. This is greater than 0.12%, that is AST minimum. It is greater than AST minimum, hence okay. Okay, now we have to calculate the spacing. Let us use 10 phi bars. Okay, therefore spacing S is equal to, what is formula? Area of 1 phi bar multiplied by B divided by AST calculated. So area of 1 phi bar, pi by 4 into 10 square multiplied by B is 3000 divided by AST. AST is 983. So spacing comes out to be 239.69 mm. So let us consider this is approximately equal to 230 mm center to center. So in the at the supports or at the joint between column strip and middle strip, we will be providing positive 10 mm 5 stirrup reinforcement at a spacing of 230 mm center to center. Okay, now we have to calculate the steel requirement for positive bending moment. Earlier was add the support, whereas now we will be calculating for the middle portion of your middle strip. Okay, so let us consider D AST for, that is steel for AST for moment, positive moment, sorry, for positive moment in middle strip. So we have AST, sorry, we have mu is given as 56 kilonewton meter, and D is equal to 190 mm, capital D is 220 mm. Okay, now we know that AST provided or AST calculated is given by 0.5 into FCK. I will directly put the values. FCK is 20, Fy is 415 into 1 minus square root of 1 minus 4.6 into mu is 56 into 10 raised to power 6 divided by FCK BD square, that is FCK is 20, B is for middle strip B is 3000 mm, and D square, that is 190 square. Multiply this with B into D, that is 3000 multiplied by D, that is 190. So we get AST is equal to 842. Just do this calculation, you will get 842.58 mm square. Okay, now to calculate the percentage AST, we have percentage AST is equal to 8 AST provided divided by cross sectional area into 100. So AST provided is 842.58 divided by B into D. B is 3000, D is 220, multiply it with 100, you will get the percentage AST. It comes out to be 0.127. this is greater than 0.12, and hence percentage, hence okay. Next step is spacing. So next step is spacing. So spacing, let us provide 10-5. okay, let us provide 10-5 bar. Spacing will be given by S is equal to pi by 4 into 10 square multiplied by 3000 divided by air AST calculated, that is 842.58. so we get spacing is equal to 279.64 mm center to center. Let us provide 10-5 provide 10-5 bars at 230 mm center to center. Okay, so in this portion also. Okay, so this is how AST is calculated. Now we will see how the steel is placed in this particular type of problem. So what we have already calculated is that whatever this is the steel drawing. Okay, we can see here in this particular figure. Okay, this dotted or dashed portion indicates that the steel reinforcement are provided. This steel reinforcement, this steel reinforcement, this steel reinforcement, these are provided at the bottom. Okay, whereas this okay, I think all are shown as a bottom, that is dashed line. Actually this should not be completely dashed. Actually near the support it should be continuous line. So this is how the steel reinforcement is provided in your flat slab. Okay, we will see next section. Okay, this is the section through column strip. This is the section through column strip. So we can see here negative steel, that is this steel is provided to resist the negative bending moment at the above, just above the column, whereas this is also negative for resisting negative bending moment, whereas this portion or this steel is provided to resist the positive bending moment. Okay, again you can see this is the section through your middle strip. Okay, again here bent up bars are provided, 50% steel reinforcement will be curtailed. Okay, here there was no requirement of shear reinforcement in this particular problem. Okay, so with this problem is over. Thank you.